spaceships from far away. We're already here on the earth today, just so small that you wouldn't believe. Travel at speeds that we couldn't conceive. That means one could slip right by, undetected to the human eye. Try to catch one, you wouldn't stand a chance, because they're just so small yet so advanced. So tiny spaceships under our noses, just so small we'd never notice. And while we're looking up at the sky, a tiny spaceship can slip right by. Tiny spaceships under our noses, just so small we'd never notice. And while we're looking up at the sky, a tiny spaceship can zip right by. What if tiny spaceships the size of gnats end up getting eaten by hungry bats, or snatched up by a frog's long tongue? The tiny spaceman would be long gone, lost on a mission as one of the few to study the giants of planet Blue. That's me and you. You wanna know why? Cause we are the aliens in their eyes. Tiny spaceships under our noses, just so small we never notice. And while we're looking up at the sky, a tiny spaceship can slip right by. Tiny spaceships under our noses, just so small we never notice. And while we're looking up at the sky, a tiny spaceship can slip right by. What if they're from a planet that's cold and gray, in a universe light years away? And even though it sounds like it's very far, what if it's the universe next to ours that makes us neighbors with a space-time fence? If the universe begins right where ours ends, a trillion galaxies and trillions of stars, and somehow they found their way to ours. In tiny spaceships under our noses, just so small we never noticed. And while we're looking up at the sky, a tiny spaceship can slip right by. Tiny spaceships under our noses, just so small we never noticed. And while we're looking up at the sky, a tiny spaceship can slip right by. Tiny spaceships, tiny spaceships, tiny spaceships, tiny spaceships.
living physical. We live up on mental. We over it intellectual. When we stand strong, on this weekend, the plans and the drums, so much power they give it. Unite, unite, as we are one. We are living Babylon. We are living Babylon. We are living Babylon. Live in this city. Go to Paris. Living Babylon. It's a spiritual. It's a over it. It's a commercial life. Living Babylon. Out of his ocean. Living Babylon. Living Babylon. Living Babylon. Living Babylon. Living Babylon. We have no time to waste around that city. If we not live today, it coulda be too late. Looking at the eyes of your brother and your sister, seeing the letters that we must do together. Big people, let's go too long. That's why we sing this song. Play pumping and drum. Open up the microphone. The energy so strong. I'm gonna time for the leaving has come.
Come inside.
It's over now. She's gone to rest. I've clasped her hands on the quiet breast. Draw back the curtain, let him collide. She'll never shrink it, let me to pride. Stars will be watching lights of angel armies in the skies to keep me from the long for day. I could not feel more far away. He said when he comes in by the city's morning dim, hoping to find fury to know. So we left but an hour ago, and stars were really watching lights of angel armies in the skies. You keep me from the longed for day. I could not feel more far away, far away, far away.
Not to kiss her by morning rain, but God has not to take her away. What will he say? God knows, not I. Good night, he said, but never goodbye.
trying for it.
Be free.
fire of life. Air fuels the fire of life. Air fuels the fire of life. Lips of God. Lips of God. Whisper the words we choose to say before your dreams fade. Let them hear what we have to say before the dream fades away. Dream fades away. Dream fades away. Lips of God. 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 Lips of God.
It's over now. She's gone to rest. I've clasped hands on the quiet breast. Draw back the curtain, let in the light. She'll never shrink, let be too bright. If stars were really watching eyes of angel armies in the skies, to keep me from the longed for day, I could not feel more far away. Will be safe when he comes in by the city's morning glow, hoping to find you to know. The sun left but an hour ago. If stars were really watching eyes of angel armies in the skies, to keep me from the longed for day, I could not feel more far away, far away, far away.
He thought to kiss her by morning rain, but God has thought to take her away. What will he say? God knows.
all sides, nowhere to run. Conversations all run now, thinking about reaching for that gun. Don't you think that I stop caring about you? But sometimes life uses you up and finishes you. Don't you think that I stop caring for you? Oh, sometimes I wanna throw my hands up, 'cause I only want the best for you. I only want the best for you. Oh, I only want the best for you. Said I only want the best for you. Yeah, I only want the best for you. Yeah. Try to hold on to all that I got, maintaining all sanity. But you see, these demons in my mind make me lose grip of reality. Oh, these voices are calling me out, instilling all kinds of doubts. But the more I try and focus, this stupor wants to control us. Don't you think, don't you think, don't you think, don't you think that don't you think that stop caring about you? But sometimes life uses you up and finishes you. Don't you think that stop caring for you? Oh, sometimes I wanna throw my hands up, 'cause I only want the best for you. I only want the best for you. Oh, I only want the best for you. Said I only want the best for you. Yeah, I only want the best for you. Yeah. Don't you think, 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 don't you think that I stop loving you? My emotions are all torn up, standing here so confused. Don't you think that don't want you? Hoping you understand that life gonna hold up the fool. Don't you think that don't you think that don't you think that don't you think that oh, have mercy, don't you think that
by cosmologists rather than astrophysicists. To define the age precisely, it isn't stars that have to be studied, but more complex structures of the universe. So why would the universe appear younger than this one star? Matthews suggests at least two possible explanations. As is so often the case with the history of science, the end result is likely to turn out to be a combination of the two versions. In short, there may be observation errors caused by something we do not fully understand, and also there may be some blanks in our knowledge of the universe's dynamics. For example, the dark matter force, which as it were has been in charge of the expansion of the universe for billions of years, is still rather baffling to us. Thus, the age paradox could well be accounted for by dark energy variations and changes in the expansion rate. According to theorists, all this may have to do with the fundamentals of the nature of gravity, in particular the causal set theory, which leads us to believe that by measuring gravitational waves, we may get to the bottom of the paradox. Gravitational waves are hard to measure. Just to give you an idea, they were first detected as recently as in 2015. Astrophysicist Stephen Feeney from the Flatiron Institute believes that a major scientific breakthrough on this front may take place in the next 1,000 years. And the bizarre phenomenon of the age of HD 140283 is bound to reveal larger and more scientifically complex things that are yet to be discovered and explored. Today we're able to access a lot of information about space objects, discoveries in astronomy and studies of prominent scientists. It is quite within our power to share this information and bring as many inquiring minds up to date as possible. This is a kind of landscape one would see in the least harsh part of a planet dubbed by scientists as Super-Earth and the closest potential candidate suitable for searching for alien life forms. But let's be consecutive. The recent past heralded a boom in discovering exoplanets. There are 4,370 exoplanets discovered in over 3,000 planetary systems so far. In addition to these, more than 3,000 objects are awaiting confirmation of their exoplanet status. Most of them are large bodies, gas giants, super-Jupiters and super-Earths. This is accounted for by technical features of the technologies used for the purpose. It is easier to look for massive bodies with a short orbital period than to try to spot smaller planets similar to the Earth or Mars in terms of dimensions. There are among exoplanets those that may realistically harbor life. There are dozens of these objects scattered in space, and they understandably draw scientists' close attention. Today we're going to look at one of these objects, which is an exoplanet dubbed Gliese 832c. In fact, this exoplanet is one of the most likely places where alien life forms will eventually be detected. This exoplanet orbits a star called Gliese 832, which lies 16 light-years away from the Sun and is part of the Grus constellation. Gliese 832 is a dim red dwarf whose luminosity is just 0.7% of that of the Sun. Both its mass and diameter are approximately 2 times smaller than those of the Sun, and its temperature reaches about 3,300 degrees Kelvin. That is the reason why the habitable zone of this planet is within quite a short range from its star. Due to tidal forces, the planets lying in the habitable zone of Gliese 832 will be tidally locked to their star, that is, will face the star with one side only, just as it is the case with the Moon and the Earth, and Mercury and the Sun. There are 2 confirmed planets orbiting Gliese 832. The Jupiter-like planet Gliese 832b was discovered first. Astronomers announced the event in 2008. With the mass 2/3 that of Jupiter, the planet orbits its parent star at a distance of an average 3.4 astronomical units, completing a full orbit every 9.4 Earth years. The discovery of the other confirmed planet, Gliese 832c, was announced in 2015 by an international team of scientists headed by Robert Wittenmeyer. It got an exceptionally high rating for its similarity to the Earth, 0.81 to be more exact, which instantly attracted both scientists and reporters. It was also nicknamed the second Earth, even though the two planets' parameters are rather different. Either way, this is one of the planets closest to the Earth with such a high Earth similarity index. The mass of Gliese 832c is 5.5 that of the Earth. It takes the planet 35 Earth days to complete a full orbit around its parent star, moving at a distance of an average 0.16 astronomical units. This is 6 times less than the distance between our Earth and the Sun. Its orbit's eccentricity is rather high, with the planet regularly leaving the habitable zone and then re-entering it. This must cause sharp temperature leaps and drops on its surface. Gliese 832c is estimated to receive approximately as much energy flux from its parent star as does the Earth from the Sun. The average surface temperature on the planet is 253 degrees Kelvin or 20 degrees Celsius below zero. It is also suggested that due to the atmosphere, which is likely to be quite dense, the temperature on the planet may be considerably higher. However, it is not easy to claim this with certainty, as Gliese 832c lies quite close to its star, and so chances are it is firmly tidally locked to it. In this case, there should be a substantial temperature difference between its sunny side and shadow side, which should regularly cause hurricane winds if the atmosphere really is dense. It's worth mentioning that in 2017, following observations, astrophysicists from the University of Texas at Arlington, the USA, put forward the hypothesis that there may be a third planet in the Gliese 832 system. Its mass could be 1 to 15 Earth masses, and it could follow a stable orbit around the center of the system 0.25 to 2 astronomical units away from it. At the moment, the planet is being searched for. Let's imagine what Gliese 832c would look like assuming life were possible on this planet. First of all, we wouldn't help noticing its gravity, which would be strikingly higher than that on our Earth. Since the planet's diameter is not yet known, the gravity force cannot be calculated exactly. Still, it would be a rocky planet similar to our Earth and Earth-like planets in terms of its density, so its gravity force would be likely to reach 2 to 400% that of the Earth. This would lead to the relief leveling out, meaning that the mountains would not be so high and the oceans not so deep. This in its turn would enhance the area of warm water, which is favorable for life. Due to a dense atmosphere and a comparatively dim sun, the landscape on Gliese 832c would be of a reddish hue, and in general the planet would be submerged in semi-darkness. Since the planet is likely to face its star with the same side at all times, the temperature on the sunny side should be high and the temperature on the shadow side quite low. In the ring-like area at the border between them, the temperature should be moderately comfortable, although due to irregular heating of the planet, the atmosphere would be constantly in turmoil, which should result in strong winds. In addition, high objects of relief potentially able to dissipate some of the force of hurricane air currents fail to form on account of high gravity conditions. As the orbit of Gliese 832c is small and elongated, seasons on this planet should change every week. It will be winter on Gliese 832c at the furthest point from its parent star, and summer at the closest approach. The tilt of the rotational axis with respect to the ecliptic plane will not be of such importance as it is in the case of the Earth. The change of season will depend exclusively on the planets getting closer to or away from its parent star. The most favorable conditions for life to develop on Gliese 832c are likely to be in the ring-like area at the border between the light and the dark sides of the planet. It is here that most liquid water will accumulate and rain down from clouds formed on the warm side. Ice caps on the dark side will also melt in the border zone, thus supplying still more water. It goes without saying that it is water that is key to developing life. The change of seasons will be likely to play the same role as lunar tides on our Earth, with areas alternately submerging and re-emerging. This process of water getting mixed with substances dissolved in it is a good prerequisite for life to originate and develop. There is a good chance of life originating in water and probably staying in it without later spreading to land. The ocean reduces the effect of gravity and protects its potential inhabitants from sharp temperature changes and hurricane winds. As for frequent and sharp changes of seasons, hypothetical organisms on Gliese 832c may learn to lapse into a state of anabiosis in order to weather unpleasant, although short, periods of high and low temperatures. Alternatively, they may choose to emigrate to a comfortable temperature zone, from the sunny side to the shadow side and back again, for example. If a space probe ever reaches the surface of Gliese 832c to investigate the area, what would it see there? Assuming life did originate on this planet, as the gravity forces are rather strong there, the potential inhabitant should be a thick-set, chunky figure boasting a robust skeleton and powerful muscles. Plants on Gliese 832c would be dark in order to attract as much light as possible. They should also be quite low and likely to be creeping or moss-like, with strong roots able to stand winds. It is highly likely that rather than chlorophyll, some other molecules should be important for photosynthesis. The planet's dense atmosphere may become a habitat for bizarre life forms floating in air currents. Single-celled microorganisms, for instance, may float in this dense atmosphere following air currents, while capturing light and nutrients dispersed in the air. Because of a dense atmosphere, high clouds and a dim sun, the surface of Gliese 832c would be a rather dark place. Life forms would have to adapt to these conditions. Vision would probably not play the decisive role in their existence, if it evolved at all. Alternatively, its spectrum may be limited to the infrared range. Be it as it may, all these speculations remain conjectures and ideas, even though they're based on good physical laws and assumptions. I wonder which of these suggestions you would call realistic and which of them bordering on fantasy. Or perhaps Gliese 832c is not habitable at all? Let us know in the comments, and let's keep in touch. To begin with, let's define what the Big Bang actually is and estimate how much power may have been released in this process. The concept of the phenomenon referred to describes the accepted cosmological model of the genesis and early life of the universe, namely, the beginning of the universe's expansion after an undefined period of being in the state of singularity. The state of singularity is the state of the universe when the density of energy was large and the space-time curve was sharp. These figures reached the Planck values. The Big Bang, on the other hand, is said to have been the starting point for the process of this energy getting released. This event can't have been anything like a dynamite stick going off in empty space. Besides, it took place literally everywhere at the same time, and it's hardly possible to pinpoint the epicenter. It is indeed hardly possible to say with certainty how it really happened and what it looked like. But one thing is clear. This was an ultimate event of enormous proportions. We're talking about an explosion that is considered to have given birth to the entire universe. In the centuries of the history of space observation, science hasn't registered any other event similar in its proportions. However, as our technologies became more advanced, scientists came to realize that there are some events taking place in deep space which are powerful to such a point that it appears that all existing models need to be questioned. One of these breakthrough discoveries was gamma-ray bursts, or GRBs. The term traditionally refers to large-scale energy emissions in space, which in fact are an everyday occurrence in the cosmos. Gamma-ray bursts are the most powerful of explosions known to science taking place in space. Shockingly, the energy released in a few seconds is tantamount to that released by the Sun in the course of 10 billion years. It was next to impossible to register gamma-ray bursts for 30 years. Even though some attempts revealed a rather exact location of a source, sources were always scattered and didn't repeat in one place. A burst didn't leave any traces whatsoever, and the best scientists could do was to identify some really remote galaxy where a burst was registered. Only in 1968 was it possible for scientists to put their finger on the phenomenon of gamma-ray bursts, all thanks to the Vela satellites of the US Air Force, whose mission was detecting possible nuclear tests in the atmosphere. According to today's views, gamma-ray bursts occur when massive stars go supernova and collapse to black holes. A powerful stream of charged particles bursts out from the hole's vicinity. On interacting with magnetic fields and cosmic radiation, these particles produce gamma rays as a result. This stream of gamma rays is powerful to such a point that such events are easily detected by satellites